Problem set 85, systems of non-linear equations. That means graphing things that are not lines, non-linear, non-lines. They're not lines. For instance, you can have a circle. If you have a cone and you cut off the top and you look at what is showing, like you pick up the tip of this cone and look at it, you would see a perfect circle. Now, if you cut it at an angle, you would see you'd have an ellipse because the circle would kind of be elongated, right? And then if you had a cone and you cut it that way, you would have what's called a parabola, right? And then if you had a cone balanced on top of a cone and you cut it, you would see two parabolas facing each other, kind of, if you just kind of looked at it, and you'd see what's called a hyperbola. Now, this stuff get to in the green book next year, but for this year, you don't have to know how to graph them because we weren't able to get there because of the corona. But if you were to graph it on a Cartesian coordinate system, and if you had a circle, sometimes there's three possibilities here. If there's a line that goes through it, okay, the line could completely miss it, and if you set the equations, if you tried to solve the system, you would get no answers if the line didn't even touch the circle. Now, the line can also touch the circle at 2 points. It can cut straight through it, 1, 2, and you would get two answers if you solved an equation something like this. Or if it just touched the circle at 1 point, like if it was a tangent, then you would only get one answer. But most of the time, you're going to get two. And if you think about it, sometimes you could get, I guess technically, four answers. Like if you did a circle on top of a hyperbola, right? You would get 1, 2, 3, 4 points where they all touched, right? You know, when you solve problems like this, you get one answer, right? Because it's two lines crossing at 1 point. So two lines crossing at 1 point are going to give you one answer, the one answer where they share the point. Well, this is going to give you two answers. It's going to give you two points where they both are touching. So I've written this problem down on my whiteboard, page 351. This is a circle, x squared plus y squared equals 9, and then this is a line. If you made this, you would get y equals 2x minus 3. And if you graph both of these, you'd see that it looks something like this. You know, here's the coordinate system, here's the circle, and you'd see something like, what did I say, y equals 2x minus 3. So it would go through here, and so you'd see it would meet at this point and this point. You don't have to know how to graph it, but there's 2 points where these intersect. Now, how do we solve for this? Well, I'm going to solve for y here. So I'm going to subtract 2x. So I get negative y equals negative 2x plus 3, because that's positive 3. But I don't want negative y. I want to know what positive y is. So what if I divide everything by negative 1? Or change every single sign, obviously. That would get y equals 2x minus 3. Okay? And that's what I said the equation on the line was. Now I'm going to plug this in. Y equals 2x minus 3. I'm going to plug it in right up to this equation. So I would get x squared plus y, whatever y is. Oh, well, that's 2x minus 3. Squared. 2x minus 3 squared. We're going to have to FOIL that. Equals 9. So let's FOIL it. X squared equals, let's see, 2x times 2x. I should probably do a visual for you. 2x minus 3, 2x minus 3. So 2x times 2x is, whoa, not equals, whoa, is 4x squared. And then I have 2x times negative 3. Well, that's negative 6x. Then I have negative 3 times 2x. That's another negative 6x. Then I have negative 3 times negative 3. That's positive 9. Equals 9. So let's combine all this stuff together. 1x squared plus 4x squared is 5x squared. And then negative 6x minus 6x, that's negative 12x. Think of your number line. You're at negative 6, you're going more negative. And then plus 9 equals 9. Well, what if I subtract 9 from each side? Gone. Gone. So that equals 0. All right. So what if I factor out an x from each of these terms? Take an x out. Wouldn't that leave me with 5x minus 12 equals 0? Oh, okay. Now we have to solve this. We have to zero it out. Well, one answer would be for x to be 0. And the other answer, whoops, right there, would be for x to be, let's see, 5x minus 12 equals 0. We need it to equal 0, right? Because this parentheses times x has to equal 0. So how can we make this parentheses equal 0? You set it equal to 0 and then solve. So plus 12, divide by 5, divide by 5. So it's 12 fifths. So those are my two x values, 0 when x is 0 and when x is 12 fifths. Now I need to plug in the x values to this line right here and solve for y values that correspond so we can get the full point. Remember, a point is always an x, then a y. So what if x is 0 in this line? 2 times 0 is 0 minus 3. 0 minus 3 is negative 3. So y would be negative 3 there. So there's one point where the circle and the line touch. 0, negative 3. Now let's plug in 12 fifths. So 12 fifths, 2 times 12 fifths. Well, that's 24 fifths. 24 fifths minus 3. Well, 3 over 1, that's 15 fifths. 24 fifths minus 15 fifths, right, is going to be 9 fifths. So look at that. 0, negative 3, and 12 fifths, 9 fifths. There it is. Here's our circle, and our line, 2x minus y equals 3, crosses it at 2 points. 0, negative 3, there's one of them. And then the other one is x is 12 fifths, which is 2 and 2 fifths. Y is 9 fifths, which is 2 and 1 fifth. So over that much, up that much. These are the 2 points where they intersect. So really it's just substitution, but you got to FOIL a little bit because we have an x squared plus y squared equals 9 here, and solve for the 2 points where this line intersects the circle. Remember, it could be 1 point, it could be no points, but Saxon 99.99% of the time gives you 2 points where these two things will intersect. Okay, I know it's a long video, but we also have this other substitution elimination here. This is getting you ready for boat in the river problems, which is another form of distance problems, but you won't get to it this year. You'll get to it in the Green Book. So this means the boat, the speed of the boat, times the time downstream plus 5 times the time of downstream equals 25. So you're going to go downstream and upstream. Remember, if you're going with the water, you're going to go a lot faster. The water's going to help you speed along. But when you go upriver, when you go against the water, it slows you down quite a bit because you have to fight the water to keep going forward. So that's all these weird things mean. But even though, see that there's nothing between the B and the TD, that's multiplication. It's B for boat times TD, which is time downriver. So I've put the dots in there. BTD plus 5TD equals 25. Excuse me, and then BTD minus 5TD equals 15. If you notice, Saxon on this problem very simply has made the TDs eliminate. So positive 5TD minus 5TD. Look at this. Look. Eliminate. So now you have to add these. You would get 2 of these things, right? It's BTD plus BTD, which is 2BTD, equals 25 plus 15, 40. So divide by 2, BTD equals 20. So that's BTD. It's 2 things. It could be 2 and 10, could be 10 and 2, 5 and 4. I don't know what it is. 20 and 1. What we need to do is plug it back into one of the original equations. You see, each one has a BTD in it. We can pick either one. So let's choose the top one. BTD plus 5TD equals 25. So if BTD is 20, plug that in here. 20 plus 5TD equals 25. Subtract 20, subtract 20. So you get 5TD equals 5. Since it's multiplied, divide by 5, opposite operation. TD, the time downriver was 1. So if the time downriver is 1, then the boat's rate, the boat must be 20. 20 times 1 is 20. So B is 20, TD is 1. Okay? Hope that makes sense. Please give me a call if you have any questions. Getting close to the end, guys. I miss you guys. Ugh. See ya.